Okay. Hello, everyone. My name is Andres Garza, and today I'm going to be going over Chapter 1, which is Introduction to the Immune System. So, this is going to be a quick run through of how our immune system essentially works, and I'm going to try to illustrate some drawings for you guys so that you can have a better understanding of how it operates. So, nonetheless, the immune system is essentially a bunch of cells and tissues in the immune system. They are organized in order to detect a bunch of different types of microbes and different types of what's it called, like viruses and bacteria. So essentially, what you can do is think of the immune system as a castle, right? And the castle or a house, right? And the house has a bunch of defense systems around it, right? The house has a fence, right, which is kind of like a wall in order to defend. And then it also has a roof with a door, and this door can open and close to people who are good, right? To good people. And then sometimes it won't open the door to people who are bad, right? It has it can kind of determine who goes in and out of the cell. And it also has a type of surveillance system, so I can put like a little camera system right here. So it's going to be watching out people, or it's going to be looking at people to see who's good and who's bad. And then on top of that, it can also have something like a light post. Ugh, that's a pretty bad light post, right? So let me fix that real quick. All right, so it's a light post, so it can kind of visualize things a little bit more, and it can see things a lot more clear. So whenever you have a house, you're always going to have people going in and out, and you want to try to maintain that house as clean as possible so that it can work effectively, right? So that's essentially our immune system. You can also think of this as a castle, as I mentioned earlier. And in that house, which is our immune system, we have a bunch of different types of cells with different types of functions. So you can also think of this as a janitor, someone who is always cleaning the house, right? So that is a mop. That's a mop. And the janitor, right, is always keeping the house up to spec and clean, right? Because if it's dirty, it's going to get messy. And if it's messy, something can end up breaking. And that also translates to your immune system becoming bad. And whenever it gets bad, it can then, the defenses won't be as well. And then you can end up getting sick. So, clean, we can say clean is a good, healthy immune system. Healthy immune system, right? That's a happy face. And then dirty, which is also overwhelmed, can also be overwhelmed. Overwhelmed, I don't know if I spelled that right, is bad, right? Is bad, and that is what's it called? That is a sick person, right? That's someone who's not well, right? Because you're overwhelmed and your surveillance system is down, so that means that your walls are broken, and you're gonna end up having someone go through and attack you. So the parts of the immune system have different functions, and we have different types of tissues as well. Tissues. So these tissues of the immune system are distributed throughout your castle, which is your body, and they consist of different types of things, such as lymphoid organs, right? And then we also have other things as well, such as the spleen, the bone marrow, right? Marrow, and other types as well. However, the main ones for our immune system are going to be our, hold on, I also missed another important one, is going to be the thymus. Thymus, right? So the two main important ones is going to be your bone marrow and your thymus. Your lymphoid organs and your spleen are also other essential parts of our immune system as well. But the bone marrow and the thymus specifically are going to be where our cells are being produced so that we can provide our immune system with healthy defenders, right? So I can go a little bit more in depth into what these consist of. So essentially what we have is various different types of cells, right? So if I can do a drawing for you guys, I'm going to provide you guys with a little chart right now. And we're going to first start off with this one special cell, and it is called a stem cell, right? Stem cell, otherwise known, or this is a multipotent, right? Multipotent hemopoietic. That's too many words, so I'm just gonna do some acronyms here. And this stem cell is essentially kind of like a magic cell that can turn into any different kind of cell, right? Whatever the body needs, this stem cell will turn into that particular cell. So whenever this stem cell multiplies or grows, it can either turn into a myeloid stem cell or a lymphoid stem cell, right? Myeloid stem cell. Oh, hold on. Let me fix this real quick. Myeloid stem cell or a lymphoid stem cell. Lymphoid stem cell, right? So it starts branching off more and more. This myeloid stem cell can turn into various types. Let me do that real quick. And then it can turn into something such as a megakaryoblast. I'm just going to put MGK, and then also a protharioblast. I'm not too sure if I explained that, if I said that correctly, and also a myeloblast, right? So all these different cells have their own unique function, and they essentially help out the immune system overall to work effectively. So after those, let me label them real quick. Monoblast, the myeloblast. Okay, and then this one's a little bit tricky to say. Proerythroblast. Problast. Okay, there. Hopefully I spelled it right. So they each have their own function, and they even break down, or they even start turning into other different types of specialized cells as well that our body uses more frequently. So the megakaryoblast will then turn into a megakaryocyte. This is a big, big, funky looking cell. Funky, right? So it's kind of like this, right? And this megakaryocyte will then even break down into creating platelets for our blood. These platelets are essentially just a bunch of little, I believe they're proteins, and they could break down, and they're essential for being in our red blood, our in our blood actually, so that it can create things such as coagulation, helping out with stopping the bleed, right? So if we have a lack of platelets in our blood, then that means that we're more prone to bleeding out more. So these platelets are extremely important. Platelets, and then megakaryocytes. Okay, and then we have our proerythroblasts, right? And these then turn into, that's an ugly arrow. Proerythroblasts turn it into reticulocytes. So these are some other funky looking cells as well. Let me write it right here. Reticulocytes. And these reticulocytes then turn into erythrocytes, which are more common cells that we're familiar with in the field of science, or like immunology. Erythrocytes, right? And this special cell right here, let me do it in red actually. This erythrocyte is actually a red blood cell, right? AKA RBC. So I'm kind of actually running out of space here, but I'm gonna try to make it as best as I can. So let me try changing a different color so you guys can maybe see it a little bit better. Go down here, and then it will go into three other subcategories as well. So the myeloblast will then turn into three different types of more frequently used cells within our body. It's going to turn into our basophils, right? It has a bunch of little dots, and then it has this one big um figure. And then we also have, let me write right here, basophil, and then we have our neutrophil, right? It goes like this. And then we have our eosinophils. And then that's that. Neutrophil and eosinophil, right? So the basophils, these little dots are granules, and that is that. The so yeah, we have the basophils, neutrophils, and eosinophils. And then from the monoblast, we then have a different kind. So we're gonna go put this arrow right here, and we're gonna have a monocyte. The monoblast then turns into a monocyte. And then the monocyte then turns into the macrophage. This one is the extremely important cell. Not that all the other cells are important, but this one is very extremely important. This macrophage is essential for consuming and for consuming a bunch of different types of foreign pathogens and germs and stuff like that, so that it could then consume and present it to our, let's say, let's put it this way. So the macrophage is kind of like the security guard. Security guard, right? So the macrophage, essentially what it does is when there's a bad person, they're doing not something they're not supposed to do, the macrophage is then going to lock the person and put them under arrest, right? Macrophage. It's going to put them under arrest, and it's going to consume them, and it's going to present them to the security's office. SO, right? This security office is going to be a specialized cell or a specialized organ such as the lymph node, aka the lymph node, LYMPH, lymph node, aka the lymph node, so that it can then process the bad person and then get rid of them. So I wouldn't want to kill this person, but I would probably just kick them out. But let's say, for example, if this was a foreign pathogen, it would kill the pathogen, right? Because it's bad and it doesn't belong there. It's not doing what it's supposed to do. So that's the job of the macrophage. Moving on to the lymphoid stem cell. This one, this lymphoid stem cell can then turn into a lymphoblast. Lymphoblast, right? And the lymphoblast, which is a cell that kind of looks like this, right? Just like any other regular cell, but they each have their own unique function, of course. So the lymphoblast then can turn into two different kinds, right? We have our natural killer cells. These are very, very, very important, similar to the job of a macrophage, but they have their own unique little job as well. So we can just put NK, natural killer cell, which is a large granular lymphocyte, right? These have a bunch of little dots around them and they are granulated, meaning that they can kill the cells, right? They're natural killer cells. They kill cells of their own body that can sometimes not be functioning properly, and they get rid of them because we don't want to have a bunch of things that aren't working in our body. We want things that are only operating efficiently. So that's the job of the natural killer cell. Uh, so the lymphoblast can then turn into something else as well, which is a small lymphocyte. Right? We want to put this one to be a little small, a little bit smaller than a natural killer cell. And this small lymphocyte, as you can see, it's called, let me just put SL. The small lymphocyte has the word lympho in it, which means lymph node. So the job of the lymph node, as I mentioned earlier, is kind of like the security's office, and this is the one that processes the bad people, the bad guys. It can then detect them, and it can also it can determine whether they should be kept or not. Most of the time, if you get sent over to the security's office, it's not a good thing. So the small lymphocyte can then turn into two different kinds, right? We have the T lymphocyte and we have the B lymphocyte. So the T lymphocyte is, let me just put it like this, and the B lymphocyte, let me just put it like this, right? Each, they're cells. I'm not an artist, right? But I'm just labeling here. So the T lymphocyte is essentially a specialized cell within your immune system, and this one develops primarily within your thymus, right? So in our immune system, we have our the cells within our immune system. They develop primarily in two different parts. So the stem cells, the so our white blood cells, or our blood, is created within the bone marrow. Okay, let me try drawing a bone if I can. That's as good as I can get. So the bone marrow. The bone marrow has stem cells within them, stem cells, and these stem cells are essentially these right here, the hematopoietic stem cells. So the hematopoietic stem cells then produce these specialized cells that we can see here, all of these cells, right? And then the lymphoblast gets sent over and they then turn into the T lymphocytes or B lymphocytes. These T lymphocytes and B lymphocytes specifically grow in two different unique areas of our body. So the B lymphocyte, sorry, I'm kind of running out of breath here. The B lymphocyte develops within the bone marrow. Okay, bone marrow. And the T lymphocyte develops within the thymus. Okay, so the bone marrow and the thymus, these are where these two different types of unique cells develop within, or develop in, and that's one unique thing about them. So another thing is that the B lymphocytes can also turn into plasma, right? This plasma cell is also extremely important. Plasma, plasma cell, right? So yeah, that's it. So that's pretty much just a general overview of the different types of cells within our immune system, and that's just to give you guys more of a visual understanding of how it works. So next we have the tissue of our immune system. So the immune system is essentially distributed through different types of lymphoid organs, as I mentioned earlier, the bone marrow, the thymus, the spleen, different types, and they just circulate throughout the blood and the lymphatic system to patrol these different types of invaders, as I showed you guys earlier, right? The bad guy, the macrophage, it arrests him, it sends him to the security's office, which is a lymph node. So whenever this happens, our immune system also can respond to bad guys or to microbes using something that is called immunologic memory. This immunologic memory is essentially what it says. So it's a memory of the immune system, right? So whenever we have a bad guy and they're doing something they're not supposed to do, the macrophage, which is a security guard, can memorize these bad guys over a period of time. So let's say, for example, whenever the bad guy does something, he puts something like a flag on them, right? So I'm just gonna put like blue hair or something. Every time it catches a bad guy, it's gonna put it's gonna put a tag on them. So it's gonna have a little blue thing on top of it. That way they can just distinguish it from regular bad guys who only did something bad for the first time. This is called immunologic and memory. Essentially, what this happens is that um, it creates a memory, right? So after an infection is cleared, something that is called memory T cells, which are and B memory T cells and B cells, they remain in the body and they provide something that is they provide a rapid and heightened response whenever you're exposed to the same pathogens as again. So this is called innate immunity. innate immunity. This innate immunity is created through memory. It can only develop if you're exposed to a certain kind of pathogen. So, oh, my bad. My bad. I am actually very wrong. It is adaptive immunity. Adaptive immunity. So, adaptive immunity is whenever you adapt to something, right? You see something more than once, you build that immunologic memory, and you have a much quicker response to something that is bad, so you don't get sick as quickly. Whereas something that is called innate immunity, right? Innate immunity. I don't even know if I spelled that right. Innate immunity only happens whenever you're exposed to something for the first time. So in that case, it would be something like whenever the security guard sees the bad person doing something bad for the first time, right? The response is going to be a little bit slower for the immune system in fighting off the infection. So let's say, for example, the security guard saw the guy doing something bad and he started asking him questions, and then he decided to take him to the security's office because he wanted to question him first to see if he was a good guy or not, as opposed to the macrophage already seeing the same guy that did something bad multiple times, and he doesn't even ask him questions, right? He just sends him straight to the security's office so that he can get questioned and probably kicked out. So that's the difference of innate immunity and adaptive immunity. And adaptive immunity is the one with immunologic memory. I'm just going to write it here so you can see. Immunologic memory. 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 Yeah, sorry. Okay. So that's that, and that pretty much just consists of the introduction to the immune system and how our body works against fighting off different types of pathogens. So all in all, the immune system is a really, it might not seem like it, but it's a very sophisticated way of protecting our body against different types of infections. And these infections could of course be consisted of innate immunity and adaptive immunity through immunologic memory or not, right? And they can distinguish between the threats, right? So understanding these concepts is pretty essential if you want to go into something such as healthcare or medicine, and it's just really important to learn. But you know, if you use different types of concepts, it makes it much more easier to understand, right? So that consists my video presentation. I want to thank you guys for listening.